I'm going to do an example from the course manual. This is example number 4, and it involves both the product and chain rule, and more importantly, how to simplify. A couple of students asked about this question, and the question is given. It's f of x equals x cubed times 5x squared plus 7 all to the power of 9. Now, to define derivative, you're going to need to use both product and chain rules. And again, it's the first term times derivative of the second plus the second times derivative of the first. And sometimes I use shorthand notation. So basically, you got a function y equals f times g. Well, the derivative is the first term, derivative of second, plus the second term, derivative of the first. Now you can reverse the order here, doesn't really matter. But that's what we're going to use here. That's what we're going to apply to this function right here. Right, it's f of x. So the derivative, f prime of x, is our first term, which is x cubed, times the derivative of our second term. And this is a chain rule. So basically this is going to be 9 5x squared plus 7 to the power of 8 times the derivative du really of 5x squared plus 7 prime plus the second term, which is again 5x squared plus 7 to the power of 9 times the derivative of the first term, and derivative of the first term, x cubed, is simply 3x squared. So right to writing. So we'll continue on. I'm going to combine this. So 9 and 3 will give me 9x cubed. Again, you've got 5x squared plus 7 to the power of 8. And the derivative of 5x squared plus 7 is simply 10x. And the second term, I'm going to put 3x squared term in front to help with factoring. It'll help you see it anyway. Times 5x squared plus 7 to the power of 9. And again, one of the problems students have here, and this is the derivative, so basically you're done. And as I often say, the hardest thing about these type of problems is simplification, is the algebra. So I'm just going to rewrite the first term. I'm going to combine this and this to give 90 x to the power of 4 times 5x squared plus 7 to the power of 8 plus our second term, which is 3x squared, 5x squared plus 7 to the power of 9. And now you simplify by factoring. Alright, you factor. And the first thing you look for factoring is a common factor. And look at the terms in front. I've got 3x squared and 90x squared. And again, 3 is common to both. And we take out the x squared term, so we factor out 3x squared. And then look at what's left. I've got 5x squared plus 7 to the power of 8 and 5x squared plus 7 to the power of 9. And of those two, again, these are both common, of those two, to the power of 8 is your lower factor, so exponent. So you take that outside, so you have 5x squared plus 7 to the power of 8. And basically you see what's left inside. And these two factors taken out are common. So if I go look at the first factor, this one right here, well, I've already taken out this term. I've taken out 3x squared here, so I'm going to be left with 30x squared in the first term. And really, you can check this by multiplying. If I had to multiply this term by 30x squared, I would get this term back right here. It's kind of messy. Hopefully you can see it. In the second term, I've taken out the 3x squared. That's this term right here. And of these terms, I've taken out 8, which means there's only one left. So it's 5x x squared plus 7 to the power of 1 if you wish. Okay, and that's basically we're almost done. And what we will do now, leave our first term alone, the outside term alone, I guess. 5x squared plus 7 to the power of 8. And then combine like terms in here. So I'm going to have 35x squared plus 7. I believe this is where the course manual ends, and this will be acceptable. But again, 7 is a common factor here. So if I took 7 outside, I have 21x squared, 5x squared plus 7 to the power of 8, and then 5x squared plus 1. And that is simplified. And it's pretty similar to an example on the assignment and one of many I'll post later in the week.